Hi everyone, it's Liam, also known by the handle Crazy Ivan here. Today we are going to talk about Vespera. This is going to be the first of two videos. Basically, the first one is going to be looking at the PixInsight weighted batch pre-processing script and conclusion with using this particular product. The second video will be about processing the photo, just to show some guides and stuff. I am going to front load this video with all of the pertinent conclusions and everything, and then go into how I reached those stuff so you don't have to like scroll through the whole lot. Thank you for watching. Anybody who's here, by the way, for the Star Trek AI upscaling, DS9 Voyager, that sort of stuff, not this video, but if you want to watch it, by all means stick around. So what we're going to talk about, let me just check my little script here. And okay. Yeah, so the conclusions that we're going to come to, this is the Vespera just on the screen here. That's the instrument I actually have. It's the Vespera Classic now, because obviously there's Vespera 2, there was Passenger, and there's going to be the upcoming Vespera Pro. The conclusions that I've reached on the weighted batch pre-processing script with PixInsight are going to be entirely dependent on the software you have available. Now, we're going to get into a little bit of PixInsight. I'm going to go into a little bit of the software and stuff as well. But if you have, for instance, app or Astro Pixel processor, it's one of the things I need to pick up. I just need to save a few pennies to get that product. Basically, that seems to post-process all of the fit files and things much easier than PixInsight does at the moment. It tends to be have less hassle with it. It just works really for a lot of large data sets. That isn't really the case with PixInsight. It's very finicky. It is very high strung, high maintenance. You can get, and in terms of my Telescope Live account stuff, where using the professional astronomy, where I've rented them out, you're talking 120 megabytes per frame. Somebody processed some AstroPixel processor stuff for me, and I managed eventually to get PixInsight to do it. PixInsight's quality was better. It just was. But it is such a chew to get to it, and that's ultimately the balance. So take the caveat of I don't have AstroPixel processor. I do have Cyril, but I haven't really studied that as of yet in depth to the level of that, and I'm still learning. So any things that I'm going to be mentioning in this video are going to be very much with that sort of caveat on it. So, right, let's get into PixInsight. So first of all, if people are interested in, you know, there is a dollar cost associated with the software. I think it's about $329 US, about 300 euro. And there's a couple of other add-ons that are also costly. I use those add-ons. It's the RC Astro stuff, the Russell Croman add-ons. So Blur, StarX, and the NoiseX stuff that he does, they are truly excellent. Now, I didn't buy them all outright. I bought PixInsight first, then a couple of months later I went and got RC Astro, just because that's what my budget allows. You may be in a different financial situation. Money might not be a problem. Money might be a problem. So I will potentially do another video. There's going to be follow-on videos to this, to be honest, outside of the initial second one, which I'll do. But I might look at free software. So there's Deep Sky, there's Cyril, as I mentioned, and how that does Vaonis Vespera stuff. Now, one of the main issues with Vespera, well, it's not main issues, but one of the things, if you look at a German equatorial mount, if you think about, like, we're taking M31, we set up our very expensive scope, you know, monochrome camera, very expensive rig that keeps it nice and still, and we track the object as we go through the sky, and it's the same picture essentially, depending on what filter you're using. And the software is really tuned to that. Now, as you'll see as we get into PixInsight, that's not what their Coval ENS or cover lens, I'm not exactly sure which pronunciation Vaonis like. And by the way, bonjour Vaonis, if anybody's watching. There's a couple of points I like to make to you as well on changes I'd like to see, so that'd be really cool. But yes, what actually their Coval ENS mode does, their mosaic mode, is it spirals round, which we'll see on the blink shortly. There's a couple of things I would like them to add, but the main conclusions are that I've reached. It's however long into this video. Sorry, 5 minutes of waffling already. Is that with the mosaic mode, with my Vespera scope, doesn't matter what size mosaic you pick, that's fine, but only let it do one loop. We can process that without too much problems. If you get it go past one, hits two, just goes a little bit in, stop it, reselect your mosaic, and do more. Basically, we want multiple TIFF files or the fits files to be output. This particular data set that I've been looking at was narrowband. I think I got up to loop 7 initially. So as you can imagine, there's been 7 whole loops. I let it go pretty much all night. And there was 1,200 odd images. The problem is, we'll see, I think it's their algorithm. But we'll get into it. Essentially, because it's literally spiraling around the central point to start with, those are the photons I want to collect. It spends a bit too much time on the parts that I'm not really bothered about. Maybe because I've selected them and they want more data. I don't know. But to me, one loop, stop, restart is my conclusion. It's what I recommend. You want multiple. It's much easier to stack that way. We can build. It's much simpler. It doesn't get lost. We don't utilize half that information purely in PixInsight. As I said, the caveat is if you have Astro Pixel Processor or some other product that I don't have at the moment, and I'm on PC, excuse me, is that you may be able to process really deep level multiple passes in that product. It tends to be much lazier about it, just gets on and does it. There's a couple of things, people, which I'll probably mention in the next video a bit more, but of where, basically just links of where I've got to. So we're going to be looking at and utilizing some of Luca Matico here. This is how I basically learned. I saw one of his videos and basically went along. There's some really quite good ones on there where you can download his own data and process them along with him in PixInsight. I've also utilized his icon set, which is on a download. Basically on this video here, you can go to here. You can download the particular data and you can see there's the 3 fit files and his icons that you can just load straight into the product. And they're the ones I've got on the thing that's open there. But there's some other really, really good YouTube. And obviously I'm going to miss some people out here. So go easy, there's Quiver Lazy Geek. Adam Block is excellent. I really need to buy his full course. I've just utilized what's free online at the moment. But he knows he is really, really good. Probably one of the few true experts on this. He's done some excellent software guides and helps with this particular product. Some of the ones that I like as well is obviously Nebula Photos. View into Space is quite good. Galactic Hunter, entering into space, there's some really good techniques and processing tips. Cosgrove Cosmos, Astro Candy, cool video in there. I like Ed just for regular stuff. But you know, I'm not going to give you a whole host that you can by all means search yourself. But the main one we'll go into on just a couple of the things is Luco as well. But anyway, right, with that said, let me just check. Yeah, so this is, as I said, Vespera Classic. It's not particularly related to Stellina because obviously it's on the Facebook group anyway, that when you go over, there's like the meridian, it flips around in terms of its the color graded on the thing. It's been mentioned before, but I don't have that particular bit of equipment, so there's that. I've mentioned that software is free. Yep, PixInsight has a cost to it. Right, we're going to go into the settings now. So I'll come back to this in a sec. Right, this is PixInsight. If you're new to it and you pretty much like I was, it can look quite intimidating. It can look like, oh, what's going on here? Once you get your head around it a little bit, it becomes a bit easier. I am certainly not an expert. I am learning myself. There's other things I'm quite good at, I've picked up on. And, you know, just moving things around here. There's a couple of other bits and pieces. You've got formats, histories, and everything like that. And then the process control windows. I've moved these around actually I followed a video just on how to configure this window. There is a couple of things I will mention on global settings that I really recommend. So as I said, this is a PC. It's a 3900K machine. It's got 96 gig of RAM on it, a lot of SSDs, and a 4090. So it's not bad. There is no such thing as too much RAM or fast storage to throw at any astrophotography stuff. As I said, some of the Telescope Live, my Telescope Live account stuff, they're 120 meg frames each. And if there's thousands of them, you know, you can fill up a lot of space very, very quickly. So if we go into the global preferences, so if you have a look at here in global preference, if you go to directories and networks, this is a really good section. And I'm not so much sure for the Macintosh fellows and folks. But on mine, A, B, C, I, and J are NVMe storage solutions. The more you add, the faster it gets, basically. It likes fast swap storage, doesn't have to peg one particular drive super fast. I've got somewhere in here as well on error. I actually just get it to continue, but I couldn't really find where that was. But yeah, it's that's one of the things I wanted to mention was the directory and structure. And if we just have a look at just a benchmark of this, it'll probably be quite slow now because I've got I have the software recording, OBS is recording, so we'll see what it does. So if we run the benchmark, see what it comes back with, just to give you a rough idea so you can have a look, see against yours maybe. But yeah, it will chug through pretty much anything, but there's no such thing as too much CPU you can throw at it. Ideally, a Threadripper build with 256 gig of RAM would be tremendous. It would be really good, super fast, but you know, there's a dollar cost attached to that. There is some money. But anyway, so and what we've got, so there we go, and that's come down quite a bit because that was at 3,200. That is halved. It was 30,000 before, so obviously running other programs as well has knocked it down a bit. But anyway, conclusions, yes. So I'm going to show you the initial data set, which was in the raw. So the way I configure my just bring up the right files here. Go. Right, so if we look at file system, okay, and I'll go to the original one. It'll be easier just because I've got less files flying around it. And again, this is just recording as I didn't want to do loads of edits. I wanted just to show you people exactly what I was doing. There it is, 2237. So we're looking at NGC 2237 here, which is the Rosette Nebula. And here we go. So this is quite literally the output. Make sure we can see that, yeah. This is the output of the contents of the telescope when I moved all the data off. I have on my settings, I have JPEGs turned off. I don't want JPEGs. Now some of you I know edit JPEGs. I don't. I prefer to edit TIFFs because I do a lot of post-processing. There is a caveat I was going to say as well. If you're just using the scope with a tablet, say an iPad or something, and you want to then just use that, maybe edit just on the iPad and then send to friends via share, then I would change my recommendation to edit image as many loops as possible. The reason being is you're not really post-processing it, shy of maybe a quick edit on an iPad. If you're using software such as this, one loop, and you'll see if you can reach the same conclusion as me when I go through and show you the various settings and things and changes. But I also have the verbosity. Basically, I have all of the test stuff as well enabled. I want all the error. I want as much feedback from the device as possible to give me when it goes wrong. It lets me have a look at all the pointing information. I can have a look at the JSON files, which is basically just the stuff. And here is all of the images. that we had. There's all the fit files. There's all the statting files, and we also have the NTIFF there, which we did. But you can see it was taking 1138, even though there was 1158. And if we have a look at the stat and JSON here, we can see that it stacked 772, so it rejected 386 images. So of the 1158, 772-ish have been utilized. But there's all our fit files. As you can see, I don't have any JPEGs. I've got a TIFF. I output all of the error stuff, and I want the fit files. So when I went through and processed, I'll show you the settings in a second, but I've kind of pre-done it because it can take a while to go through. When I went through with just, I'll bring them all up actually, so you can see that one. So what we're looking at here is the execution monitor going through. I'll go through what each of these are. But this one here is with the, I'll show you in a second, but the default settings in terms of WPP when you include it. This also included 75 dark frames. I will add that I did have dark frame data. If I just bring that back. Yes. So if we look here, I did actually have darks. So you can see there's 75 darks I took. And it's important you take them at the same temperature. So in here, 17 Celsius, I'm not sure what that is in Fahrenheit. But when I take it outside, I leave it scope outside for about 45 minutes to bring it right down to ambient. I want no warm air anywhere in the device. So when it starts to image, it's at the same temperature as outside, because it's very important. If I take darks at 17 Celsius and it's imaging at 1 Celsius, that's not going to work. So very, very important to take your darks in the expert mode in the app, Singularity app, at the right temperature. So yes. Okay, now this was the default settings. So you can see here it's 1158. It went through. I'll show you the plate solving. If you pick, just leave it as auto, what some of you may have found, if you've tried this yourselves, it'll just error. It'll stop dead at the resolving because of the nature of what Covel ENS mode is doing. It's spiraling round like this. You're going to see that in the blink file in a second. And this is how I've reached my conclusions. So essentially, it's doing a few things. I didn't really like the result. You're going to see in a second the results from this one. This is with slightly tuned settings on by me. You'll see it. It's okay, but it's not quite very good. And as I also included a solution that Ian on the forum had come up with, just in terms of being a bit easier for the plate resolving, where it uses triangles. It's not as accurate. It can get itself a little bit mixed up, but I tried to include it like as a combination anyway. But I also have, just to mention as well, CUDA is enabled. Quiver Laser Geek's got if you've got an NVIDIA graphics card, if you're on PC, I'm not sure if it's for Macintosh, but it may be, it may not be. But you can go through and you can actually have CUDA accelerated. So for instance, some of these like blur and noise, these will actually work with CUDA, and you can go from something that takes a minute to something that takes 5 seconds or even faster, depending on how fast your rig is. These are the icons, as I mentioned before. I don't know why it's going so damn slow, but there you go. These are the ones that Luke have. Mine are a lot more all over the place. I didn't want to delude you too. We're going to use these a lot more in the second video, so don't worry too much about them. But if we have a look at, this is the TIFF file. So this is the raw TIFF that gets output. That's that 1138 that you can see there. First thing I do is I usually will resave it as a native format that PixInsight has, because if I bring that file in, I'll just bring that file in now so you can see what I'm going to just briefly talk about. So if we come all the way down, and then bring this file in. Now, it will come in like this because it's in a linear format. What that means is everything on the sensor runs all the way past. If you ever look at a histogram of this, so if you have a look at the histogram, so process, histogram transformation, there's a big spike just over here where they actually need to set the view to the it's TIFF. You can see there's a big spike. All the data, all the information is sat over here. So when somebody asked me what I meant by the word stretching in the forum, and I basically just mean all the data gets stretched across the entire spectrum here. Well, that's not the right word, but in terms of from shadows to highlights all the way across. So shadows, mid-tones to highlights. And that's all we're doing essentially. But at the moment, the picture's in linear format. What you can do, there's a process called STF where you can just come in here and we can just get it to show us the file. Now, when we look at the file itself and we have a look at its fits header, this is a TIFF. It will not have one. There is no file. So that is, I believe it's flexible image. FIT stands for flexible image. My brain's gone blank. Let me just Google that again. I think that is flexible image transport system. Yes. Oh, brain. Right. So, but as a TIFF, it doesn't have any of the information. I'll get into that a little bit, just showing you how the FIT files do have a little bit. And these are one of the recommendations I want to go to Vaonis specifically for its Coval ANS mode that will really, really help things like PixInsight. But anyway, first thing I do is I resave this as a native format, because this is PixInsight considers this and FITS as outdated. It's not very good. So it wants to resave as an XISF, which is a native format. So you just come in here, file, save as XISF, and away you go. Then what I do is I image solve this particular thing here. So script, image analysis, image solver. I come to search. Oh yes, I need to tell one other thing as well after this. NGC. This one is 2237. There it is there. I then put in the date that this particular image was taken. Now the focal range, if you're like, oh, I don't really know what this is, for Vaonis Vespera, it's 2.9 microns with a focal distance of 200. You can get that straight from the website. If we scroll down, you know that its focal length is 200. It has an image sensor, the Sony IMX462, and you're like, okay, where's that information? We know it's an f4 ratio. The Pro will be f5. But if you just scroll up here, it mentions small yet powerful. CMOS sensor with a 1, a 2.8 format, and a 2.9 micron pixel size. Ding, 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 we have a winner. So what I then do is I put in my location here, which I'll not do because I'll tell you exactly where I am, but I would then put in this location as well, and then I hit OK, and it image solves. Now, one cool thing, which I'm not sure most people have, or do, but when you get PixInsight, if we have a look at here, this is just a screen grab I took of PixInsight webpage because you log in to download, because obviously you buy yourself a license. As I said, it's about $329 US, about 300 euros. And what you then do, just get rid of this for a second, go, is you can see on here there is the Gaia DR3 and Gaia DR3 SP datasets. If you can and you have the space, download these, both of these datasets, all of these particular files here. They're quite big, they're 3 gig each, and put them on fast internal storage. So for on PC, I've got a 4 terabyte C drive. It's NVMe. It's the new PCI. I'm not sure if it's PCI Express 5, but it's at least 4. So it's, you know, it's doing a good turn of speed. I've put all of these files on there because it uses them when it looks at SPCC. So the spec basically, tell you, I'll show you. So when we come down to do color calibration, spectrophotometric color calibration, it will reference these. If you do image solving, it will reference these. The way to actually put these put these files in once you've downloaded them from here. All of these don't use DR2, it's an older data set. Gaia, this is the latest Gaia data set of the one in orbit, the Gaia satellite. It's scanning the sky basically, and we can utilize the data that they've put in here. These other ones are also related. You can get things like ones that look specifically for meteors and comets and things flying around, so you can identify them if you annotate your images, but that's a discussion for another time. But if you pull all these files down, the DR3, I like the complete data set for both. Then what you do, process, you come down to Gaia. As you can see here, we have Gaia, DR3, DR things. If you come to the little tool and you see DR3, you can see on my C drive, I have all of them pre-selected. And DR3 SP, I have all of those pre-selected. What that means is when you go to image solve, that Gaia data is already there. So as you can see, if I just come in here, or the TIFF file when I've then saved it as XIF, script, image solver. And in here, put in the information, the time it was taken, 200, which is our scope. For Vespera, it's 2.9 micron pixel size. You just leave this all as automatic, and it will then look at that data on the C drive and just run it much quicker than going out to the internet, back and forward, super slow. It is really, really, really a fast speed up. Highly recommend you do that. Anyway, so we now have our XIF file. Now, when we come to the batch processing, this is the topic in question. It's only taken me nearly half an hour to get here. Wow. Apologies. Trying to get through as much as possible. Yeah. Yes, we'll get onto that in a second. I'll just clear all of this data. Reset. So essentially, all this is doing is scripting stuff that can be done manually through the actual program itself, just each step manually. With the docs, it's rather easy. You can go into directory, but I prefer to load just the files myself. So if we load in, I'm just going to go into the information. And go into docs. So I'm just going to essentially load the information showing you what to do. There's our docs loaded in. Don't touch any of this. Super easy. Go into lights. We want our lights. And we want to go into initial images. And you want to load all of them in. You do not want to include the TIFF file or the other file that you've saved. Again, this is for the entire lot. This is not what I recommend, obviously, now. It would just be one loop through, but you can imagine there's one loop. We're going to go through the one loop anyway, but I just want to show you what I did initially on configuration. It will take a while there it goes. It loads in all of those FITS files. Now, it doesn't have any information on the ascension or declination information. And this is an important point I would like. I'm just going to exit that. By the way, if you exit it and you go back into it again, which we will in a second, but if you go back there, it will remember what you've just done. So as you can see, it will remember that we've got lights and we've got docs loaded. So don't be like, oh, I forgot to do something, I need to go back in. It will do it for you. You can see they're all still there. The lights are all still there. Now, if we have a look, this is an image from a different... Okay, that's weird. Probably need, it's not been turned off for a few days. It's probably having a bit of a problem. But if we have a look at the FITS file, this is mainly for Vaonis. See the information. In fact, I'll do a one over here as well. So these are exactly, this is just a fits file and an XIF file of the same thing. This is just the fits header that's in currently. Vaonis, we don't really need the white balanced information. You don't really need to report that back. The bare pattern is very useful, and we can use that for the WPP script. Exposure time, basically what we need to happen because of the nature of the beast of what's going on with Coval ENS mode, we really need to know the right ascension and declination of where you're pointing. If that's doable or put-inable, it would help so very much. So very much. So just to give you an idea, this is that one. If we look at this one here, you can see right ascension, declination. That would, if I loaded that file in there, it would then show. In fact, I'll do that. But basically, that lets it know where in the heck it's looking at. We don't have that information from this one. There is nothing in there to say where this has been looked at. If we get that, it will be huge. Absolutely huge. So, come back to weighted batch pre-processing. Now, previously what people have probably tried, you've probably tried this already. If you have this particular program and you have a little bit of confidence in it, one thing that's quite nice is you click on the calibration here. If I click these files, you can see that it's these darks are related to it because it knows the exposure is the same. Now, because we're not with really expensive $3,000 plus cameras and rigs and massive telescopes, we're not using a monochrome camera. So this is a one-shot color. You need to make sure that's ticked. It will be anyway. It probably recognizes it. Now, the mosaic pattern, as we saw before, was GBRG for this. If you have stellina, it will be different, especially when it crosses the meridian. So you need to pay attention to that. Okay. I also have a cosmetic correction, which I'm going to show you in a second. I use it for hot pixels. I highly recommend you include it as well. And I just drag it to the desktop. I'm going to show you that in just a second. You can use automatic or literal. You can stick on automatic for the moment. I've not seen any major differences for me. Global preference, it runs bottom down or bottom up even. Most other things are top down. Vaonis tends to like bottom up. Now this is the registration reference. Most people will have just left that auto, that have picked a directory and then ran it, and it would have errored or stopped at that registration. What I tend to do is go to manual, put in that XISF image. It's just the TIFF that you've saved and you've image solved. That now has image data in there. Now, we're still not quite finished. This is on calibration, remember. We can come back and have a look at our lights. This is the default. So when I was talking about before, about this slot, this is the default one. This is what I mean by default. Sort of just kinds to be the standard, how it's going to weight the images. This is one slight change over here that I would recommend, this particular one. So this is the default in terms of just using PSF signal weight. What I changed that to myself is PSF scale SNR. And I also come down to image integrate and I change the minimum weight to 0.5. Now, those of you familiar with Adam Block's stuff, especially his free WPP stuff, it goes in, obviously, when the paid course stuff, you'll go into every single minutia on why he's selecting things, what's the methodology behind it. He is very good. Very good. And again, I need to get that course. Just need to save some pennies with all the things I need to buy. So again, highly recommend Adam's stuff if you really are wanting to learn PixInsight. Yeah, so 0.5 on the minimum weight. That's all I tend to do for that. So that is where my tweak settings, image registration. Now, one thing that Ian mention, and it is quite useful if you are still having an issue, is you can move noise reduction up to 1 or 2 and then use triangle similarity. I tried without that to start with, maybe just 1 on the noise reduction, because this is the good thing is if you hold it over, it'll tell you exactly what it does. Image registration will use triangles instead of polygon descriptors for star matching routines, but it's less accurate. To start with, I don't really want it. Image registration, yep, so just got the noise reduction on 1. Astrometric solution, again, I then search for NGC 2377. It was 20, no, it's not 2377, idiot. It's 2237. I did that the other day as well. Oh, dear me. Yeah, it's having a problem with the old kernel there. I think this thing needs to be restarted. Yeah. So yeah, it's having a bit of a problem. Yeah, I'm gonna have to restart PixInsight in a second. But you would put in there, you put in the time and date, that would be 200. As we said before, that's 2.9, okay? Local normalization, leave that as fine. You want the integration of best frames. And is there anything else that I need to do? Bottom up is important. Manual, you want to put the image, make sure you put it decent. I prefer the output directory to be on a different SSD for maximum speed. We've gone through there. I'm going to show you the CC auto in a second. We're GBRG for Vespera. Post calibration. Now, post calibration. This exposure tolerance, if you, I mean, it's not really with our scope, but if you had a telescope where you had a 200-second run and then a one with 600 seconds, if you crank that, you could make it so instead of creating 2 separate images, it would merge them together and weight them equally. So that's where you tell it its exposure tolerance. You can also, one thing that's pretty cool as well, is if you notice there, we can get it. Obviously, it's going to take more time to do this script, but you can get it to output RGB and the full image. So if you want to then go in and just tweak red and just tweak green, you can get it to do that, which is really, really quite nice. But in this case, I'm just going to do the combined. Now, drizzle, I like drizzle. Now, I tend to do drizzle for when I'm pretty sure that I've got it dialed in okay. To start with, initially, the new features is they've got fast integration, just to see that it looks roughly okay. I think this is a fairly new one that they've brought in, and it's much quicker than going through the full script. So there's fast integration there. But once you get to the drizzle, I like to 2x drizzle it at a drizzle scale of 0.9. Okay? And that'll then add that to the script as well. So we'll go through, and the reason why we drizzle it, I'll just briefly talk on this before we get back to CC, is that the scope is slightly undersampled. Now, if you think about a professional rig that's going on, like the ones I rent down in Chile, it's just taking an image, it's going across the sky, and it's taking the same image all the time. Now, if there's any particular issue with pixels, hot pixels, things like that, what you can do is you can dither it. It's a little bit more time consuming, it's more costly. But what we do is we move the telescope ever so slightly. And what that's doing is, just by moving it slightly differently, it's getting all of that just covered off, because when it's stacking it, there's different ways the pixels aren't in the same spot every single time, and it aids with being dithered. So it helps out with our hot pixels and any issues with the image, because you're getting different parts of your sensor is imaging that particular part of the sky. Now, because we have cov-LENS mode, we're already, because of the spiral, moving around the image. That's kind of covered. But one of the main difficulties, and why I think PixInsight and a few other things have difficulty with it, is that most every astrophotography solution is looking at a still image going across. Ours is still moving across the sky, but it's spinning all over the place. So this is a problem that when you want to do subframe comparisons, I'm not going to touch on that in this one, but you can get it to measure and check stars. You really want to be using that to check the TIFFs, I think, or be the output in the TIFF images. against each other rather than that. Because if you're over here and there's just a few stars, whereas if you're the main object, you're say M31, there's a hell of a lot more stars if we're looking at the core of it against something well off to the left. So yes, there is that. But yeah, so drizzle helps us because what it does is it examines like a single pixel for a star, and you can rebuild, and it looks much better. We're going to show an example of that in a second. Down here, I'll have to reload it, but it's not a problem. Anything else? Yes, I included over here hot pixels, didn't I? A cosmetic correction feature. What you do is cosmetic correction is up here. We want to use hot pixels or use auto detect hot sigma. The default 3 is fine. You can have that unticked because CFA is part of the, it gets that data from the process itself. And now this is quite interesting in terms of some of the, if you're not familiar with PixInsight, this is how it drags an instance. This just kind of runs it, and this is like a preview. In this case, I want to run an instance of this off, so I drag it to the desktop and it's there. And then as you can see, I've just renamed this. It's definitely having a problem. I can rename this, and this one I've renamed CC Auto. You can have different levels of, if you want to use the Dark Master, and you can have them, imagine you had different runs of the graphics when you're coming down on the BPP. So I'll just bring that back up again just to demonstrate. And it isn't so much with our scope, but you can imagine if you had different runs that you were processing down here. So different filters, say, and you wanted a different cosmetic correction applied to them, you can do. You can just have multiple that's then saved down. So you can see there's process 30, but in this one, that's there. So this is the main change that I've done. Instead of letting it be auto, pick the final image that was out there. The problem is, I'm going to show you now, is the blink. Now, I'm going to B. Right. I'm just going to close this down and reopen it because I think it's going to be a problem. Yes. Right. We'll load it up again. Just to show you what mine looks like, which is why I didn't want to get into there. So this video is recorded at the end of January of 2024. This might be, they might have completely developed everything that they've done between now and then. As you can see, there's a hell of a lot more in mine. I didn't want to like have people go, what the hell's that? And just nope out of it. One cool thing here, I've got 5 updates, so that's pretty cool. So one of the cool things is you can have repositories. We can then check for repositories. This is how we get in some of the cool scripts. So basically people develop things that PixInsight can use, and you can tell it the location. It keeps an eye on those locations, and then it will then go and do this. So you're about to see, yep, I want to install. Yes, please. I'm now going to go into here and go into here, here, and go here. Nope, go there, there. Yeah. Yep, okay. Now, as you saw before, look, I can never remember his blinking full. Where are we? Look at Matigo. There we go. Is done that data you can download on his website here. This is essentially it. And I'm going to just drag his icons. Ta-da! There you go. And across. You might get an error too if you don't have, for say, the Russell Croman add-ons. You know, there is a cost to these, but I use them on every single image. And if you're going to go this solution, even if you get them a few months later, they are highly recommended. I can highly recommend them. They are excellent. There are free alternatives. There's StarNet V2 for star removal and a few other bits and pieces as well that you can have that does a version of what these do. Topaz as well. I use Topaz on my AI upscaling, Star Trek. But they also do for noise cancellation. There's denoise options. But again, there's less here. They're just basically all these are is just quick things through to here that are pre-configured, and we're going to go into them on the second video. But anyway, so I did mention how I reach my conclusions. Well, as you saw, we have a lot of images. And I bring the images back. Here we go. As you can see, there is a tremendous amount of images. You're like going, okay, well, what's the first step you've done? You've just showed me one where you picked all the files, and we got to this. And so that, with the settings I just showed you before, that is essentially what I did. And that is the outcome of what it did. It took all of them. As you see, it rejected 953, which tends to be when Vespera goes over. This is one of the things that I've spent so long investigating here. It tends to keep the core, and it's why I recommend what I've recommended, and you're about to see why, because I'm going to go through a useful feature called Blink. And Blink is up here. What you can do is tell it where all those fit files are. And again, I want all the fit files. I do not want TIFF or the XIS I've saved. It's then going to load all that information in. Really, really, really useful. This is probably the most useful thing to see what actually happens when your scope goes flying around. And one of the key differences here is you'll see on this and this. This is all images, regardless of anything thrown in, put through the process. This is pretty much the same settings in WBPP, but I have pruned just the good quality images by using Blink. And again, it's down to a matter of time. If you've got, hell, I ain't got no time for that, I'm just going to process TIFFs, fine. But are you going to get the very, very best quality? Probably not. It all depends how much time you want to put into getting the absolute top quality from the images. If you put in rubbish, they could eventually get put in the stack. Yes, the software and the routines are very good for removing things that aren't of good enough quality, but you might get one or two that sneak in. It can affect things. If I go in and pre-check every single image, the clouds, or was not tracking properly or anything like that, then I know that only good quality information is going in. Therefore, in theory, I should result with a better image quality. So as you can see, I trimmed it down to 850, which is more than the 772 that the scope initially stacked, which is interesting. Now, let's have a look. So what you can then do is you just hit apply automatic display function. This is just pre-stretching, still in linear format, the images. And let's go through here, just to bring this out a bit. So as you can see, there is the image. Now I'm going to just run play and let's see what happens. So as you can see, it's going round. And usually what you'll find is when you do an automated image solve, the first 100 or so images will always solve properly. Once you get to a certain point where it's going miles away here, as you can see, we've just clipped the left of it. Now we're at the bottom. Then we're going up over the side, over here, and then back down the other side. We're not really imaging the Rosette Nebula here. We're going all the way around the outside still. Then occasionally it jumps around different sections. I'm not re-imaging. You see the things over there, and it's stuck a little bit. And then we're imaging not the nebula, where it's like imaging the corners. You know, we're at 500 there, and I'm still not back at the Rosette Nebula. Yeah? So, I'm just going to roll through. We'll carry on in a second. I just want to show you. Watch where the first one, you can kind of see it. Yeah? They're the photons I want to be collecting. Right? Yes, I want to have a little bit round it because I've drawn the particular area. But in this particular example, I don't have nebulosity all over the place. Now, you might do, depending on the target you've got, in which case this is okay. But what I would suggest is one loop only. As soon as it's gone into 2, stop it, redraw your thing. Doesn't matter if you're exact again, but be pretty good on roughly what you want. What I used to do is I just take a photo with the iPad once I've drawn the mosaic, just because I can reference it, what I drew. Even if you're off, it moves a different. Remember that dithering that we said before, because we're moving around, it's going to dither it. That's good for us in the long run. As you can see here, it's spending 20 odd images on sections that aren't the Rosette Nebula. There's a corner there, the Rosette Nebula up there. Oh, there it is there. And we're bouncing around. There it is there. Okay. So it could utilize a couple of them, and they will be on the image solve. It will utilize them. Now you can see, or you can start to see, why I was getting so many getting rejected, because we're not hanging round the Rosette Nebula, we're jumping all over the place. Yeah, so blink is very, very useful, just to see. Obviously I've got it set at the moment to quite quick, so it's just jumping around. It lets you see what happened on your imaging session, and I really, really like to blink. First off, I'll just watch it a couple of times like this, try and see here. Oh, yep, this is what I want to image. This is great. I'm imaging it. These are the photons I want to collect. Everything's great. Yep. This is going to bring out that nebulosity that I want to see. Once I've got to about 200 and something odd, I'm off, out to the races. So we're doing a giant circle here. We're up to the top right. Then we're coming over the top left. Then we're coming down to the bottom left. Then we're right at the bottom on the right hand side, and we are stuck in imaging stuff. Yeah, I'd have stopped this by now, and I'll be back doing my other one. So now, what other things can you use with blink? Well, quite a lot. Remember, I told you I pruned at 850 images. As you can see, I'm just zooming in and out. Just use my mouse scroll wheel. It hasn't had you can see it still might look a bit like a mosaic because these haven't been debayed yet, but these are just raw files. What I like is I can either get it to play, or I can set a different time, so I can have each image at 1 second, or I can just right click myself and go through. Now I know that these are, quite nice. They're nice and round stars. There's no major issue. I've got my nebulosity there that I want to see. But when I get to, you'll see it in a second. I believe it's, they're not on this one. That's clever. I've moved them. Because all of the ones in here are good quality. I've already done these. You can see how they're quite nice. Let me show you what happens when they're not quite nice. And what I do is, well, I'll show you. Say, for instance, this one wasn't very good. It was streaky. There was nastiness everywhere. What you can do down here, I create a folder called Blink Bad. Okay, and then what I do is, there's the little thing down here, move selected files to new location. And then say, where do you want it? And then just stick it into Blink Bad, and it will then move that file off. Note, it doesn't remove it from the blink list. The only way to remove it from the blink list, well, actually, you can select multiple. I could select multiple here, and then hit this one, which says close selected images. Now, usually what happens when I'm imaging these, and I'm finding with this scope, it'll be like good, 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 bad one, the next one's good. So in which case I just use the drop there. Sometimes it will get into a period where it's been really windy or something's gone wrong, where I'll get good, 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 bad, 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 good. In which case I just gradually select them all and then I'll move them. Or I just go in Windows Explorer and move those particular files into the Blink Bad folder. That's what I mean by how much time you want to put into it. Again, the same principle. Once I've got a lovely prune list, I can then put that into WPP. Now, be aware that because we're actually moving around, if you've got a period of bad ones that are actually core files that we're spinning around, we're going to have less data, which is why multiple nights is good, which is why having just that individual multiple TIFFs is going to be really good. top tip then, from my point of view, with all the stuff I've gone through, it is a nightmare on PixInsight to try and stack 1100 files. It doesn't like it. Once it gets to the corner, once you've gone past and it goes quite a way, you're going to see in a second how far it goes. It goes a blinking long way. I don't like it, because what we end up with is, let me just show you here. I want to look at this one. Do our auto stretch. Yeah, so this was the result of this one. So where I'd gone in, put the whole lot in, and just done my tweak settings, and it uses the registration in there. You can see it has a right problem with the stuff at the left. It rejected 954. This is only using 194 of the images. Yeah, there it comes in. I'll just bring up the original TIFF so you can see. Where are you, TIFF? Right, there's the TIFF file. And if we just temporarily, you can also come up to here. There's icons at the TIFF for the auto stretch. You can have auto stretch boosted. You don't have to use these particular ones. You just go off there. So as you can see, you're thinking, oh well, why are you even making this video? Just use TIFFs. Well, actually, no. The reason being is when it works. Do you see how noisy it gets when you get right into this? Yeah. This is just this particular one. It isn't even using very many images, but it tends to be quite clean. I went and done what I used to do was I would each of those, as you saw, each of those fit files, the files that are here, I would image solve, because I showed you before when you load one in, yeah, it doesn't have any of the right ascension or declination details that we need, that Vaonis really, please put in to the fit file that we can actually utilize. So when we drag it in, that it then has that information. So I'll give you an idea of what I mean. So when it goes into weighted batch pre-processing, if it had that image, the astrometric solution, it would then show on the light. You'd be able to see it here. Right ascension, declination, focal length of 200, pixel size of 2.9. If it had this information, it isn't a problem, because it knows exactly where in the sky it's looking. It can then integrate them properly, which is why I'm saying I don't have Astro Pixel Processor. It's probably less problematic. It'll do its own solve and it'll just do it. This is a really good product, but it's very highly strung. When it comes out, it's looked great, but when it doesn't, you get errors around all over the place. It can be a pain in the butt. Now, where was my completed? I believe it's under 6. Let me just have a look. Where are you? Oh, there we are. So this is the TIFF, yeah? That is the TIFF as saved by just the scope at the end. This is me going in and image solving every single fit file, pruning them to 850. Actually, I image solved all the 850 first. I'm going to go back to blur and blink in a second. But as you can see, where it's gone in, look how much time it's spent. Let's move this across a bit. Imaging stuff over here where I don't really care much about at all. Yeah? Anybody see Rosette Nebula anywhere here? And you're thinking, oh, I'll just draw a smaller box for your thing. Yeah, you can do that. But at the same point, it images tremendous amount of stuff over here. You'll have seen that a little bit on the blink. Now, again, if we just come in, this is just integrated. This isn't drizzled. Bear in mind, because where this telescope is slightly undersampled in terms of the pixels, your pixel size, you can get it to look a lot better than this. You can see how even at this point, when we haven't even drizzled it, There's a lot less noise. So if you can be bothered to put in the time, if quality is absolutely your top concern, then TIFFs are out the window. They're a really good, super quick source, but if you want the very best that the scope can do, they ain't good enough, basically. I'm going to show you an example now where we actually will process something. But I'm just going to go quickly back to the blink, just to show, because you've seen blink with good quality stuff where you can see each of the stuff in here is nice. They're quite sharp. You'll see what I mean as I go in. There's nice. There's not like streaks on the stars. They're nicely round. It's good nebulosity. Obviously, it still has the Bayer pattern because I'm being debated. But you can see that they're quite nice. When we get rid of this and open up another location, let's have a look at, say, blink bad. This is going to be fun. Let's see what bad looks like. What I've pruned off, so you can see. And has it added them into the entire list? Or has it added them at the bottom? That's weird. Okay, close all images. Let's do this again. I don't know what it did there, but it didn't do what I wanted it to. This is definitely a way of making it work. And again, this is how you know it's live, because I haven't pre-prepped everything. I've tried to pre-prep as much, but there we go. So if we have a look and we zoom in, because initially you're thinking, what's wrong with that? That looks okay. You know, got some nebulosity in there. As you can see, when you go into it, there's a little bit of egg-shaped stars. They're starting to elongate. And remember, I'm wanting the highest quality image that I can get, and I'm prepared to do this over multiple nights, multiple weeks, multiple months, multiple years. If I can combine the really top quality, you see that one, don't know what the hell happened there. There's a couple where you'll see, well, hey, you can see how it's bad, then we literally get double stars. Again, the algorithm's probably rejected these for the TIFF, because it did reject quite a few. But as you can see, we have, it spent ages. I mean, how many images were there? 20 images just on one particular part of the sky. There's the rosette over there. We're all the way over here doing bouncing. Now, it was really windy when I took these, so I will give the scope some credit with the algorithm. It's probably like, hey, I need to take this part of the sky. Will you stop being so windy? And you can see there's nebulosity that I've even taken out there. But the rest of the images, they're just, I can't use this for solving. It looks like there's double stars everywhere. And this is what I'm saying, and this is what I mean by the pruning off the blink bad stuff. So that is blink, and that is why I've had a look at the image. Because every single blink that I've checked, the first at least 150, 200 of them are just going round like this around the core part of whatever I tend to put on the mosaic, the center, little cross right on the bit that I'm interested in on the nebula. So the Heart Nebula recently was the core part of it, where all the new stars are blasting out and lighting up the nebula. And that gives me the first 100, 150, the photons that I'm trying to collect. I don't want to bother about collecting miles over here. Don't care. Just want the core stuff. I can get that later on and then put in like because this is narrowband, I can put in full broadband if I need the stars in there. Now, let's get to processing one now anyway. So, what do I mean on that? So, if we come into batch processing, we are going to restart. Oh, come on, batch processing. We're going to reset. We're going to reset all of our things, clear all the files. It's done. Now, this particular one was taken, data set was taken a while ago. It is here. There it is. So we are going to output to a file on there. Just do B. There we go. We are going to load in. It doesn't have any darks for this one, so it's just lights. And we are going to go into here. We are going to go into that one. Going to go into 6B. No. And as you can see, there is 190 fit files. And I'm not including the TIFFs. Okay. I'll just show you again. I've added them in there. Observation time. It has that, but it doesn't know any of the other information on there. We don't have any rate ascension. I'm just going to quickly close it. It will save it, remember. We're going to load into that folder. 6B. I want to load in the TIFF and that. So again, just do a quick stretch. Yep. So that is the TIFF. I then immediately have saved it as a native format, XISF. When I save it as XISF, overwrite, yes, I always save it as 32-bit. The reason being is there's a lot of things on here where you need 32-bit precision. Don't just save it as 16, 32 is better. Takes more space, but welcome to astrophotography. Then hit OK, job's a good one. Then you are left with the XIS file. Remember, script, image analysis, image solver. We then put in the location. I'll then put this in here. This would be M13. M13, Messier 13. Focal 200, as we know by now, we are 2.9. I then put in the location that I'm at. I'll just put it off here. You can see it, then I'll stick in my details. And then I'll bring it back, and you can see the processing on here. I think it's that. I live in the West. That. And I live at a height of that, and then I run. And as you can see, it's now going to consult that Gaia data that is on C drive. And it will then go and match exactly there. So it tells us the image center is a right ascension 1641, 41.693, the declination. Top left, top right, bottom left, bottom right. That is super important. And then when we come into our fits header, we've got our data there. That can be then read. And when we come now into batch processing, weighted batch pre-processing, it still remembers our lights are there. There's our lights, still there. We want to go, I've still got that set. I'm going to go to manual because none of these have an astrometric solution on them. Please, Vaonis. We then come into down here and then want to load up the XISF, which now has astrometric data in it. Remember, we are bottom up for the fits orientation on this particular scope. I don't have any dark information. Calibration. I want to make sure that now I don't have a color correction here, which I need to do, so I'll exit that out. I come back into cosmetic correction. I want to use a auto detect of a hot sigma of 3. Drag an instance down here. Rename it CC Auto, or whatever. You call whatever you want. I'm calling it CC Auto. We then load back up our weighted batch pre-processing. So this is an example of me just to remind you, showing you what happened over the small one. So this is only 130 odd. So this is scanning that area. It's not done multiple 7s, 8, 9 loops. I don't want to do that with PixInsight. So there we are, cosmetic corrections in. I'll use the literal value. Could be either. Everything all right there. Yes, it is. Post calibration. Again, you can go that separate if you wanted to, so it'll separate them out if you really want to get into your post-processing. You can see it's got the incorrect exposure time here. It's not reading it right. It's saying 10,000. It's not. It's not 528 hours for DME. But let's just go combined. We are going to enable a 2x drizzle, and we're going to do it at 0.9. We're not going to do fast integration on this one. That's how really good if you want to just do a first run through. It's really quite good. There's no multiple exposure times. I don't have anything like that. This is going to give you a rough pipeline of what's going to happen. Now, into our lights. I do not want to go default. I'm going to go to my PSF scale SNR. We're going to the minimum weight of 0.5. Basically being that I don't want, if it's worse, if it comes rated out as below than 0.5, I don't want its quality. Now bear in mind that may have a knock on because we're spinning around, just be aware of that. But I don't want anything there, and you can see it's still 0.5 now, rather than 5%. Local normalization, they're fine. Integration of the bed frames, please. Astrometric solution, we are going to look at M13. I still put it in just because I do, Messier 13. This was taken on the 2023, 3rd, 15th, at, it ain't taken then. That's not right. It was, let's see, this is the other problem as well. I know that PixInsight has a problem on observation stuff when it goes over 60 or something. There is a script I saw somebody release. They are working on doing a better version of this, so hopefully this video becomes redundant and it's as good as or better than AstroPixel processor. We'll see. But I think I took this at like, let's just say 2300. It's good enough. Focal distance is 200, 2.9. You can or cannot force. I just tend to leave it like that. Happy there. Registration. I will do noise reduction of 1. I'm not going to use triangle similarity. Right, I believe I'm pretty okay to run that now. Got no darks, I've got no biases. Even when you add, if you add bias, you don't need to touch all of these settings. They're great. If you add darks, don't need to touch this. If you add flats, pretty much don't touch any of these. We don't have these yet. We have darks, but hopefully the Pro will give us all of these. Now, there's all my settings done. Yep, 0.5. Yep, happy with it. Calibration. CC auto. Oh, nearly. See? GBRG. Got it. That's important because that is how we're going to get debated properly. And you can see filter CLS makes no difference to PixInsight because it's just pulling data from the fits header. And run it. Yep, it's all green. Now, that's going to run. And as you can see, it's doing the cosmetic correction to start with. It's basically removing the hot pixels. I like the dark stuff for that as well because it has all of that lovely in. And if we, obviously that feature wasn't available when I took this particular image. And we're going to compare both the TIFF now. We're going to let this run, so we're going to run in real time. But we're going to compare the TIFF to the output of this and also the drizzle integration of 2. And see, hopefully, what happens. I might even put in a SPCC just to show you how that's done as well. Great. So while that's going on, let's recap. Just a reminder, my recommendation for the Vespera Classic, again, this is what I'm going to be doing now, because every image I use on this is Coval ANS or Coval Lens or whatever it's particularly called. The reason being is I want to get rid of, if it's just tracking and observing it, we run into the stuff where we're undersampled and we're just keeping the same parts of the image on there. It's not going to look as good. Coval ANS is great. I don't want it to do multiple loops. Only do that is if you're staying just on a tablet and then you're sharing it, airdropping it or emailing it to some friends, family, whoever. If you're going to do post-processing on a computer, you want multiple TIFFs. It's going to be so much easier to then stack either the fits or just the TIFFs themselves, get them saved as the XISF files, get them solved, get them cleaned up, and then they can just stack them. And it's, well, actually, you do the stacking first, but that is the way to do it. You want multiple files down there, then the signal strength builds up. You don't want to let, because it's just, as you saw, if it's windy, it's busy taking photos all over the place on the corners. I don't care. I want the photons from the object. Now, if the object you're looking at is the entire frame, that's different. You've got to use your head about it. So there's that. Is there anything else that I need to also mention? Yeah, just thank you very much to the script. Well, actually, while that's doing that, we'll just have a quick look at the so here.
I've got a bit of a day to share video for you today. Hope you're all doing really well. I've got a bit of a day to share video for you today, combining with a kind of a tutorial, if you will, where we're going to tackle some heart nebula data, which I captured just a few nights ago. It was around about 5 hours taken with an Aries M Pro camera, which is a 5.
So if you want to process this and you're thinking, how do I get the pixel size? How do I get the focal length of what he's using? You've told you that he's using an Aries M Pro camera. Google is your friend.
Mono sensor through my Redcat 51 and some...
And he's using a Redcat 51. So you can get the focal length of a Redcat 51 and away you go.
6nm filters.
So as you can see, I'm just going to quickly skip through. There's the data he loads it in. There's his icons.
This kind of
and he walks you through various stages. And I actually utilized an older video. There was an older video, a series of them, about 5. They were the first ones I watched. They were really, really useful for PixInsight. And then I just grew from there. So top shout out to Luco and Quev. He's got loads of the stuff on there. I used his CUDA video. He reviews a lot of stuff. Adam Block, top quality as well. And there's a whole load of other people as well. Entering into space, View into space, Cosgrove. Everybody has really, really good information. It all depends on how much time you want to do it. I picked PixInsight particularly because... Oh, what's it doing here? What is your problem? Okay, only one active frame. What? That's not right. What? Grizzle skipped. Okay, so it's made a bit of a difference. What happened there? One active frame, you say? Did I pick the right image? Yes. What did it do? That is very strange. And again, this is the problem with PixInsight. Sometimes it can come out registered. There is no master. So debayed all of them. Yes, it did. So just drop in an image from the debayer. Just stretch it. Yeah, you know, it's debayed it. That's fine. What say you in terms of what the problem was? Okay, let's try again. Let us try again. And the good thing is, because it's created those files, we don't need to do them again. Let us just tweak something here. I wonder if it's because I didn't pick the noise cancellation. Oh, it can be, and this is what I mean. Welcome to the wonderful world of why the hell didn't it process? This is the problem that we've got. So if we then take off, no, where? We'll go to the registration. Take off noise reduction. Oh, actually no. You know what I might have done? I might have used triangle similarity. Let's just try this. Because I don't have all of the data there. Right. PF scale, 0.5, calibration, GBRG, yep. Okay, let's run it again. Now, it'll just, you see how it's cached? It's already done all of this work. There's no need to redo these ponds. Let's just see what it does on this registration side of things. So it's looking through, there we go. So it's registering all of the images. This is the part we only had one register there for some reason. And I don't want it to do that. And this is the thing, I've actually had the exact same script give me different answers with the exact same files. So it is very, very powerful. It is very, very good. It's only doing stuff you can do manually. You can do all of this manually at each individual step. You see, 182 registered, 08 failed. Okay, but you can do every single bit of this script as a single step and just do it manually, but they decided to do this. It is very, very good. There's not many other videos that have had a Vaonis Vespera focus that are doing PixInsight. Some of the settings that I've taken even from Adam's free stuff that he's got there and from other people are looking at proper scopes, proper monochrome lenses where the image is the same across there. Because of Coval ENS, it brings in all of the problems because we're spiraling out and it's doing various things because you might get wind and it's taking multiple images. It becomes a problem. We can't then evaluate this image against this image. It's looking at a different part of the sky, which is why we're going to image them. The other thing is I'll do another video because this is getting on for ages now. Jesus, now on 10 minutes. Christ. where this is going to be looking at subframe selector and things as well. But I just want to quickly get through this. Nobody's probably watching at this point, and if you are, well done. Congratulations for sticking with me. But I wanted to show just as much as I could on this. And the last thing I'll do with whatever image, we're going to go through the integration and the drizzle and the TIFF just to compare, because I think it's worth it, even though it wants to make me pull my hair out after I've done. I didn't blink these, bear in mind. I didn't blink any of these. I just accepted all of them. So if I was going to do this properly, I would blink each of the images just to make sure there's no bad ones have come through. But this was a shot from M13 a while ago. And it's now normalizing it, which is good. And again, it's using the scaling system that we mentioned before. So that, I don't know whether that was the case of the triangle similarity was needed for this particular one. I'm almost sure it wasn't though. But yeah, I still do have the old data because I did save the stuff. We'll let this go. I can't really show you until it's finished anyway, but I do have it. It's now integrating the image. And you can see your PC or laptop or Mac may have a completely different spec. You may have no memory. I've only got 96 gig of RAM on this. Some of you might be going, what do you mean you've only got 96 gig? That's miles more than me. On my old 128 gig, I was literally hitting the memory limit. So really, I would like, if money was no object, I'd have a Threadripper 64 core 128 thread, or an Epic or the Xenon, and I'd have 256 gig of RAM, probably 384 gig of RAM, ECC memory, and that would be great because it just loads everything into RAM super quick. But yes, so one of the plans this year is to double the RAM on this to 192 gig, which will really help with my AI upscaling and astrophotography. So yes, we're waiting on this. Come on, integration, you can do it. But is there any other topics that I need to briefly mention or wrap up? So we've talked about blink. We've talked about the cosmetic correction, getting rid of hot pixels. Very useful thing to do. We've talked about the debayer settings, which is GBRG, I believe. I've talked about the settings inside of PixInsight that I have. So I have CUDA acceleration. I have as much of the SSDs. I just list one. I list as all the spaces. I created a folder just for scratch space so PixInsight can utilize it to run faster. Multiple SSDs. I have on error, just continue. I can't remember where I put that in, but it's there. And you can see it's calculating the astrometric solution there of the image. It's now going into the 2x drizzle. I've shown you blink, how to move bad blinks over. We've gone through the WPP script. We've shown you the main change that you've probably done is you've probably let it to be auto. You've put all your fit files in, you've just hit run and it's errored. Now the options are you either image solve every single fit file, which is the best solution, but it's really time consuming. Most people are just like, I ain't got time for that, I'm going to use the TIFF. But it is best to get through a script of some sort because it is worth it for image quality. And again, if we get more and more, excuse me, my nose is itchy. If we get through more and more images that you've taken over days and weeks and months and years, and you want to then stack all them together, well, this is a way to potentially do that. But for me right now, one loop of whatever mosaic you've selected with Coval ANS, let it get through one, let it get to two, let it take a couple of images or just get a little bit way through the top bar, stop it, redo it again. Now, you may be going to bed and then letting it go overnight, in which case that's not really realistic. But the best way to do it, if you want to post-process with PixInsight, as of January in this particular version and this particular version of their script, I think I've heard they're working on it. They really are working on it. I like this part here where it actually does the astrometric solution again for the drizzle integration. Right. Hooray, I think that's that done. Right. Lovely. And this now wants to do the image cut out of the crop. I forgot to select. I'm just going to cancel it. I'm not bothered about the crop. Don't bothered about the crop. Go away. Thank you very much. 2 crops done. We're not going to use that though. So I'm just going to hit reset just for next time. Reset all the parameters. Okay, so it goes in next time. Right, let's have a look at them. So let us bring what you've just literally done right now. No, so I need to go to A, it was going to BVV, and I want to look into master, which is what we've done. So we have in hell with the auto crop. I want the light file, master light file. So what you'll see here is there's 3 images load up. This one, if I stretch it, this is all of the stuff that, bear in mind, on blinks, by the way, I forgot to mention that, on blinking, if you see satellite streaks, you don't need to remove them, you don't need to pull them out of the stack. The stacking itself will remove them. So if you see a giant satellite screaming across, don't worry about it, that can still be part of the stack as long as the rest of the image is sharp. You can see exactly here, that's been removed. So this is all the high stuff that's gone. There's the low stuff that's gone, and here is the image. So that is the TIFF. This is the processed image. Going to come in there in a second. And then I'm also going to load up the 2x drizzle. And the 2x drizzle, which basically doubles our resolution. Now, let us go in and just have a look. You can go away, you can go away. Right, we're going to have a look at this. We're going to have a look at this. We're going to have a look at this. So, standard TIFF. Right, let's zoom right in onto M13 here. Let's have a look at what our processed is, and let's have a look at what our 2x drizzle is. Now, don't worry too much about the colors at the moment, but I think this, especially the core here, there is much better clarity. Remember, we are undersampled. This scope undersamples with camera size, the pixel sizes. This is better. I don't know about you, but that has greater clarity than just the TIFF. I can start to make out it's not smeared as much, just merging as one, the core of M13 here. And this, I think, will respond better to the AI stuff. Now, this is, I think, it's double the size, obviously, because it's 2x'd. I think this is probably the best of the lot. In terms of, you look there, it's just there. I can make out individual structure. Now, what I would do, let's say, for instance, on this image, the last thing I want to do, because this video is getting on for, oh my days long. So, I'll quickly show you how you do what I do. Spectral photo color calibration. So, I'm going to leave it there. Now, Sony sensor, you have a cut. I don't think I took this. No, this is just broadband data. If it was narrowband, then that changes to photon flux. But as it's just broadband, I'm going to leave it average spiral. QE is fine. If it does go to narrowband, I also make it sort of just the optolong I'll enhance. Tends to do a good enough job. Or I'll make a narrowband and I select the bandwidth, I believe, of the Vaonis ones is 12 nanometer. So, but anyway, you know, this one's fine. I want to then now pick a part of the sky which doesn't have much stars in it. But first of all, I've got to press the new preview mode here. So I'm going to come down just that bit there. There's not much in the way of stars in it. Okay. Then want to pick a region of interest. We're going to hit from preview, the preview one. It's going to use the Gaia data with the spectral photometric data. Color correction, it's going to generate me a graph and do it. Now this, if I drag this over to there, it'll do it. But I can just hit, because I've got this one selected, I just execute there. It's then going to go and apply the color calibration correctly on there. And as you can see, we've got a fairly decent match, which is quite good. And if you're wondering why the hell is it white, it's because it's still remembering our auto stretch. We have to come in and we have to reset. We link it because it's been done there, and then we just stretch it. And there you go. I want to delete the previews. And that is this now color corrected. And if we compare that, get rid of you, thank you very much, against this. This is our TIFF, remember. This is, it's cleaner, it's got a better detail in it. Once we roll in blur, not that much, let's say we'll do 80% blur, just instance onto there. And you can now see what CUDA does. This is still in a linear state. Processing, and how fast was that? 11 seconds. There you go. Obviously that's a little bit too much. We need to go in and adjust that, but you can see how easy it is just to get started. Anyway, I have gone on for so long. Hopefully that was of use. There's going to be a second video which will be much shorter, which will be about processing the nebula shot. We'll do either Rosetta or the heart. I'll just go through and show you exactly using these. I'll not use mine, I'll use the ones that are available from Nucamatica, or you can use it live, or you can watch his videos. But since some people might not want to do that, I'm quite happy to show you just how to do that. So the first video is up. My conclusions again, go through with Vespera Classic, let one full instance go through, one full loop, stop it, restart it again. You want multiple TIFFs. Therefore, all the 100, 200 odd fit files, which will be easy to process. As you've just seen, you do it in PixInsight there with M13. It'll go through and it will process them. You don't have to image solve. You saw all of them didn't have an astrometric solution. That is my recommendation for the scope. For Vaonis, thank you very much for a lovely device. It's really cool. Could we please have the fit file headers have that right ascension and declination data of what it thinks it's looking at embedded in the file, so that PixInsight and other software can utilize it. That would be great. Crazy Ivan here, let's go Liam, and yeah, that's this file. I will try and get this up as soon as possible. Hopefully that's of use, and if you've made it this far, congratulations, you are officially insane. Thank you very much everybody, bye bye. See you in the next one.